Hello everyone, I'm Raf, the Director for the Institute for Marine Research here in Dauin. And welcome to our last of our methodology series. Today's methodology is going to be impacts. Now here at IMR we have our own definition of what we consider an impact in our surveys, and an impact is any process, whether it be natural or unnatural, that results in the reduced health of the reef. Explicitly hard coral species. So when we talk about impacts, we're talking about the impacts on the reef building corals that are found in our area. Now, for impacts we have a wide variety of categories, and I'm going to go through them one by one, kind of giving you a little taste of what it is we measure and why. And we're starting off with one of the most obvious impacts that there is to be found out there on the coral reef, and that is coral disease. Now, coral disease is any kind of impairment of the bodily functions of a coral. Now, this impairment can be biotic or it can be abiotic. The causes can vary, and it can be sometimes hard to pinpoint what is causing a disease and what isn't. But it's important to understand the prevalence of disease in ecosystems to know if an ecosystem is in fact healthy or if it's being found under attack. When studying coral disease, it's important to focus on what we know and what we don't know. The reason for this is that there's a lot that we don't know. Coral disease research started on the back foot because it started pretty late in the game. We're talking about the first real coral disease studies starting in the 70s and 60s. And this was just because we were getting that first influx of divers. Diving wasn't really a thing before then, so it was hard to study corals in their own environment, and thus really hard to identify or even notice coral diseases. So, what this means is that there is no baseline to go off of. This can be quite concerning due to the fact that we're trying to compare healthy reefs versus non-healthy reefs, and we have no idea what a healthy reef is supposed to look like pathogen-wise, because we have no idea how reefs look like before human influence. We can gain some idea by studying pristine reefs, which are really far from human interaction, but even the most pristine reefs have already been affected by human action. Among many of the things that we don't know is, are these pathogens new or not? We know for a fact that there are at least a couple of pathogens that have been introduced into coral reef environments entirely by humans. And we know that these pathogens have been quite deadly. But we don't know the prevalence of all the pathogens that were already in the water by the time we started studying them. So we don't know if they're natural or not. Was it humans that caused this pathogen to be everywhere? Or was it a naturally occurring pathogen which only mutated because of certain conditions created by humans? Or maybe it has nothing to do with humans at all. And every once in a while a pathogen just mutates and goes crazy on some coral. The truth is, we don't know the answer to these questions, but we can make some educated guesses. Another thing we don't know is the movement of water through the world when it comes to coral disease prevalence. Ballast water has been important to the influx of invasive species, but it could also be a problem when it comes to coral disease due to the fact that it involves the bringing of new pathogens that could be in water. Nowadays, ships have complex UV systems to make sure that the water inside of their ballast doesn't contaminate that much, but this is a fairly new development that definitely did not exist in all the years of shipping that came before that. It's also interesting to look at coral resistance. We don't quite know how coral's immune system works to the extent that we wish we knew it. A lot of that is because corals have an amazing microbiome inside them. It's not just corals and their little algae which help them gain food. There's also a giant myriad of different viruses, bacteria, and other microorganisms that live inside corals, and it's hard to know how they all work together. There's a lot of research going into it right now, and it's very exciting. As much as we don't know about coral disease, there is a lot that we do know, thanks to the great efforts made by scientists all over the world. Among these things that have been discovered have been a great catalog of coral diseases. These catalogs have helped map the spread of disease and the prevalence of disease worldwide. While there's still a lot of holes, every single new paper that comes out gives us an insight into what the world of coral disease looks like. And it's really, really cool. It's very interesting and very complex. We know that diseases are spread worldwide. There isn't a single coral reef anywhere in the world that doesn't have coral diseases, which seems to indicate that these diseases have been around for a really long time. Whether it has been to this scale or if all of these diseases have been around everywhere is hard to say, but we do know that disease is a natural part of a coral reef environment. Now, another thing that we know is that coral reef diseases can spread through the water column. Now, unlike the air that we breathe, that we're surrounded by, all up in here, it's actually way easier for a virus or bacteria or plasmid to survive in the water column. There's not as much oxygen, which is very reactive, as you guys know, and can be quite harmful for microorganisms, and there isn't the harmful UV light, which is, always found coming from our sun. Underwater, these microorganisms are much more protected from this and makes their spread much easier. This leads to some pretty interesting stuff. For example, sometimes corals are found to be having diseases, certain disease-causing microbes inside of them, but show no signs of the disease, which seems to indicate there's some kind of immunity that could be present when corals are really healthy. And it might be that only when corals' immune systems go down that they actually get sick. There are coral diseases that actually use intermediaries, like snails and fish, to actually spread the disease around, which is also really, really interesting. Now, another thing that we know is that, and this is kind of like the most worrying of the parts, is that a lot of these diseases have actually been, not a lot, but some of the diseases have been introduced by humans entirely. These are diseases that didn't exist before we came along, and then because we introduced a certain pathogen into the ecosystem, it has now become a problem. The second thing we look at here in our impact methodology is bleaching. Now, bleaching, a lot of you guys already know about it. It's been on the news, etc., etc., etc. But it kind of represents one of the single most impactful events that can happen on a coral reef, having the ability to decimate coral reefs on a wide scale throughout species. The reason why this is so important is because unlike coral diseases, which tend to focus on a few specific genera or a few specific growth forms, bleaching just covers the entire reef. And when you have mass bleaching of a large impactful scale, like we've seen over the past few years, what you'll notice is that it affects every coral genre out on that reef and can lead to phase shifting. Phase shifting is when a coral reef stops being a coral reef and actually becomes something else, whether it's an algae patch or a sand patch or a rubble patch. It completely changes what it is, and essentially because all the reef-building corals which make a coral reef have died. Next up, we come to another big celebrity of the impact world in corals, and that's the crown of thorns starfish. The reason why this little invertebrate is so impactful and thus so famous worldwide is because it has the ability to really decimate corals if it goes into outbreak behavior. Now, crown thorn starfish are actually the fourth most destructive impact on the coral reef after cyclones, climate change, and sea level rise. This means that they can wipe out entire reefs, and their destructive ability is very scary to look at. Now, crown thorn starfish are actually naturally prevalent in coral reefs. They're there, it's normal. However, when they go into outbreak mode, that is to say you have way more crown of thorns than you should, they can destroy reefs. What causes that shift from normal populations to outbreak is human impact. Now, this is normally in the form of nutrients. Crown of thorns, when they're little tiny babies floating across the water column, they don't even look like starfish, they feed on plankton. Now, coral reefs tend to live in areas where there is not much plankton. That's kind of the point of coral reefs. The only reason that they're able to survive is because there is not much plankton between the surface and the coral reef, thus allowing a lot of energy from the sun to be able to be absorbed by the coral reef itself. So these crown of thorns normally have really high death rates for their young, and only a few make it to adulthood. However, when humans stick their foot in it, they have the ability to create massive amounts of plankton through the outpouring of nutrients. Normally, this comes from farmland in the form of just runoff coming from farms, or sometimes from aquaculture. When you have this big runoff, you have the ability to create big algal blooms. These blooms become food for the crown of thorns, which can then propagate in numbers that they never could under normal conditions. These crown of thorns then descend onto a reef, and they start an outbreak cycle. Outbreaks of crown of thorns last years. We're going to have a video that goes way more into crown of thorns, so I don't want to completely ruin that. However, it must be said that their breeding ability during an impact cycle can be very, very large, and it goes with the current. So you can actually have an outbreak that starts in one place, and then as these crown of thorns breed, they then move from place to place to place with the prevailing current. And that's why it's important to not only keep a watch here in Dauin, but also be in contact with our partners across the Philippines to know where outbreaks are happening so we can be ready in case one's coming our way. Now we come to the last invertebrate on our list, out of 2, whatever. It's Drupella. Drupella is a tiny little snail and not as famous as our good old friends, the crown of thorns starfish. Drupellas are tiny little snails, and again, they go through outbreak cycles. Their outbreak cycles don't look like crown of thorns, which can cover an entire reef. They tend to congregate in a big locust swarm of snails. They congregate in one area, and then they clean it dry, and you can see kind of a lawnmower just moving across the reef, eating and eating and eating and eating. Then they tend to congregate around faster growing corals, like branching corals. Now, not very much is known about Drupella outbreaks and their overall impact, how much humans weigh into the equation, all this kind of stuff, which is a big reason why we're trying to really focus in on them and see their impact here in our coral reefs. Now we've come to the last impact that we write down, and that is trash. Trash, we split it up into 2. We have fishing trash, and we have just your normal everyday garbage that is thrown into the ocean. Sad. Now, one thing that we've noticed is that the amount of impact that trash has on a coral reef depends mainly on 2 things. 1, the current, and 2, how much fishing takes place in that reef. Reason for this, when the currents come in, if it pools in a certain area, it means that trash, which is normally just floating around on the surface of the ocean or in mid-water, has the opportunity to sink down and actually impact the reef directly in a hurtful manner. Whereas when you have coral reefs like we do in the northern part of our surveys here in Dauin, the current is so swift and moving that it's actually pretty hard for much of the trash to actually get deposited onto the reef. Now fishing, that's a pretty straightforward one. If a reef is being fished, then you have a lot of potential for a fishing line to get tangled along with nets and other fishing materials. Here in the Philippines, there's actually quite an interesting bit of fishing that happens where a net is put around in a circle. Then a group of fishermen will throw rocks in the middle of the net to scare the fish into the net. These are gill nets. They're very good at catching fish when they're trying to swim through them. And they all get caught up in there, which will then be hoisted up onto the boat, and then all the fish will be taken away. Another interesting fishing method, which has the potential to be hurtful here in the Philippines, is fish traps. Fish traps are woven out of bamboo. They're big old squares, and they have a funnel. Pretty straightforward. They put some kind of bait in there. The fish, attracted by the smell, go into the funnel, can't find their way out, they're fished up. As a fishing method, it's actually quite selective. Any fish which is not what they want to eat can be thrown overboard. The problem comes when these traps are set onto the coral reef. They can be quite harmful via direct destruction. Now, fishing is illegal in every single one of the NPAs here in Dauin. So the presence or not presence of fishing gear is pretty much equivalent to the presence or not presence of illegal activity. So this gives us a good view of how well each NPA is being managed. When it comes to our impact analysis, it's done via visual survey. That is to say, we go around and we look at for any disease, any crown of thorns, any Drupella, any trash, or any other kind of impact really that we can find underneath that calls our eye. So how is that done? Well, you have a GoPro right now, and you have a sizing stick. And what you proceed to do is look for any impact. If you find an impact, say a diseased coral, you will then take 3 dimensions of it. That is its height, its length, and its width. Bloop. When you have these three measurements, it will give you an area of what has been damaged. So we put this into our database and we can monitor it through time. Now when it comes to crown of thorns, not only do we take pictures of the impacted area, but we also take pictures of the crown of thorns. Why, you ask? That is a great question, imaginary crowd that doesn't watch these videos. What happens is a crown of thorns can be aged depending on its size. So if you're finding a lot of little ones, chances are these are newcomers, and they're actually not coming from your reef, but they're settling down after an invasion might have happened on another reef. If they're big fat mamas, then what they're doing is actually spreading their eggs through the water column. Now, as we take pictures of all of these impacts, we compile them, and then we compare them to all the other data that we have. Now, there are pros and cons, of course, as there have been in every single one of these methodologies. The pros is that you have picture evidence. That is to say, you have the ability to audit all of these results. This is key in every aspect of research which is done through the Institute for Marine Research. We make sure that you're able to look back at pictures and you're able to audit these pictures to make sure that mistakes aren't being made or aren't being repeated. This gives us the ability to let citizen scientists and other people do the data collection, do the data analysis, knowing that we can always go back and check on it later. Now, it does have its cons, and that is the tank. You can only look as long as your tank lasts. So there's always a chance that you will miss something because of time or deco constraints, as always happens with any kind of data analysis that takes place with data collection underwater. Now, another good thing that we have, another pro, going back and forth between the pros and cons now, doesn't matter. Another pro that we have on this data is actually that we have the ability to look at the pictures on land. That means that we don't write down anything underwater, it's all pictures. If we take the pictures and bring them back here, we can actually have books to look at to be able to correctly identify each impact, correctly identify the coral that is being impacted, which is also important to know which genre is being affected. And it gives us the ability, if we're really bamboozled, we can send this picture to a coral expert or a coral disease expert to be able to look at and be like, oh, this is this is that, this is that. So, all around, I think it's a pretty good method. Now, this has been the last of our methodology series, but please keep in touch because we will be going over the analysis series, that is the analysis of all the data that we do, which will include a look at all of our software and all of kind of the analysis that we do behind the scenes to put out the awesome reports which you can check out on our website. So stay tuned, guys, and have a nice day.